예, 두 번째 예제로, so the second example is the type checking. So as I said, the type checking is a very important thing in a program language. So let's consider this a simple example. So in this example, we assume there are only three variable A, B, C, like we, for the simplicity. 우리 일단은 A, B, C 변수 세 개만 쓸 수 있다. And the right side of the assignment can be either a variable or an expression in the form of a variable added to another variable. 그래서 우리가 assignment의 right side는 variable 하나가 오거나 또는 뭐 두 개가 올 수 있는데 더하기만 된다. So for example, we can just allow just one variable or two variable with addition. And each variable, so each variable has two types. So A can be integer or B can be real. 우리가 데이터 타입이 두 개만 있다라고. So we just simply to the simplify, we just assume two data type, integer and real. So when there are two variables on the right side, for example, this, they need to be the same type. They need not to be the same type. That means it allows integer. Yeah, obviously it allows integer plus integer, right? So, but this statement means we allow integer plus float, real. So we allow this one. If the type of expression are not the same, it is real. That means if we add integer plus the integer, then the type becomes integer. So 우리가 그런 의미고, real 더하기 real은 데이터 타입이 real이 된다, 뭐 그런 의미고요. 만약에 두 개가 다르면 integer 더하기 real이면 결과가 뭐가 된다는 건가요? real이 된다. 자, 이런 룰을 일반적인 룰이죠. And the last thing is so we wanna check we want left side assignment must match the type of the right side assignment. That means A is B. So if A is integer and B is integer, so it's okay. Let's say C is real. Then A is C. This is error because the type of left side should be matching the right side of the right side, the type of right side. So this is error. Another error may be A is B plus C because B is integer, C is real. So because integer plus real is real, so the result becomes real and right side is integer. So it does not match. So this is also error. Okay. So we want to check this kind of, in this example, we want to check this kind of error. So we want to describe these rules using attribute grammar. 그래서 이렇게 아주 간단한 프로그래밍 언어, 이렇게 아주 짧은 언어지만은 이렇게 인테저 리얼 경우에 오른쪽이랑 왼쪽에 타입 체킹, 타입이 맞는 거를 기술을 하고 싶어요. 이거 역시 이제 우리가 BNF로는 안 된다. 예. So how to describe this rule using a attribute grammar? This is some actually it is the same as a BNF. So basically we have some syntax rule. So assignment becomes variable equal expression. So expression means variable plus variable or variable. The variable means, I think this should be, variable means A or B or C. Okay. So this is just a basic context-free grammar. Attribute grammar, we can so in order to check the type checking, we add two attributes for each non-terminal. So actual type is for variable and expression, and for expression we add expected type. So we add two property. One is actual time, second is expected time. And just remember, this is just added a new property, new attribute to check type checking. 그래서 attribute type, actual type이랑 expect type이라는 것을 우리가 추가를 했습니다. 그 말은 우리가 뭐죠? 우리가 뭐 바에 so that means bar that actual type. So we can use this property or expr that expected type. So we have two attributes. So we can access by using dot. 우리가 dot actual type, dot expected type이라는 우리가 성질을 우리가 부가를 한 겁니다. 그래서 우리가 쓸 수가 있고요. Yeah, so this is the syntax rule, and we have. So let's see this one. So if you see this in the PDF, you can find the same, the exact the same thing. So this is the BNF form. Yeah. So by this rule, we can check the syntax, but we cannot check the type checking. So this is the attribute grammar rule. So as you see, there are, compared to BNF form, it has many rules. So basically, it has the first. So we just extend for this first rule. We specify more. First, the syntax rule is the same as BNF, and we add another semantic rule. So this is the attribute graph. So it's like a variable actual time becomes the right side expected time. Okay. So this is a rule. So there are many ways, but this is one of such rules. So the right side is expr that expected type is set by variable that actual type. 그래서 우리가 variable의 actual type이 결정이 되면 그 값이 expr의 expected type로 우리가 값을 세팅한다. 우리가 시메트 룰이다. 이런 의미가 되겠다. 그거에 대한 룰이다. Okay, let's see the second rule. Yeah. Syntax rule is the same. Yeah. So at this time, we give number second and third, okay, to distinguish two variables. So semantic rule is the expression that the actual type is determined by this rule. So how to determine if variable 2 that actual type is integer and integer, then result is integer, otherwise real. So if you see this rule, it all includes integer plus integer, then result is integer. So otherwise, for example, integer plus real is real, or real plus real is also real. Real plus integer is also real. So it includes this rule. So this is a semantic rule. And at this time, we need some predicate. So it should satisfy this predicate. EXPR, the actual type, should be EXPR's expected type. Okay. So this is a predicate rule. So the actual type should be same as expected type. So we will see why this should be required. And third, for this rule, the semantic is the same, syntax is the same, Symmetric rule is the variable actual type is define the expression actual type, and the predicate should be same. Yeah, the actual type should be same as the expected type. And this one, yeah, syntax rule is variable means A or B or C. The semantic rules, variable that actual type is determined by lookup function. So lookup is another function. Lookup function looks up a given variable name in the symbol table. So we have actually another. So in this example, we did not specify. Maybe there is another rule. A is int. Maybe B is float, real. Then we analyze the syntax and we store it for each variable, whether it is integer or real. So this lookup function returns the type of each variable. If it declares integer, then it returns int. If it declares real, it returns real. 그래서 우리가 lookup function이라는 걸 둬서 어떤 변수의 타입을 우리가 어떻게든 알 수 있다. 그리고 지금 보시는 것처럼 이렇게 타입 체킹을 하기 위해서 BNF라면은 신텍스 룰은 이렇게 아주 단순하지만 이거는 타입 체킹을 할 수 없다 그랬죠. 그래서 그거를 다 체킹하기 위해서 그럼 액티브 그래프 룰은 어떻게 되는가? 뭐 한 네 줄이 아니라 이렇게 각 룰에 대해서 신텍스 룰, 시멘틱스 룰, 신텍스 룰, 시멘틱스 룰 필요하면은 프레디킷 이런 식으로 우리가 다 이렇게 다 추가를 하면 이제 이 룰에 따르면은 아까 했던 타입 체킹이 가능하다. 네. 어떻게 가능하냐? 그건 이제 결국은 하나의 주어진 이게 우리가 A는 so for example if we have A는 A plus B, if we follow this rule and if we declare A, B as integer real, then we can check whether type checking by following this rule. So that means we need some method to compute, compute or to check whether this is correct according to this rule.